Assalamualaikum warahmatullahi wabarakatuh. This is assignment BEET 2333 Communication Principle, Semester 1 2021-2022. Topic for this assignment is Pulse Code Modulation PCM. Our lecturer name is Abdul Halim bin Dahalan. Next, my name is Farah Nabihah binti Ramlan. My group members are Haiqal bin Idris, Hanif bin Jamaluddin, and Jevitha Gunalan. For the introduction, as we know, the pulse code modulation is a digital scheme for transmitting analog data. A signal in pulse code modulation is pulse code modulated to convert its analog information into a binary sequence. To obtain a PCM signal from an analog signal at the source transmitter of a communication circuit, the analog signal is sampled at regular time intervals. The sampling rate is several times the maximum frequency of the analog signal. PCM offers the advantage over other modulation methods in its resistance to noise and its ability to reproduce digitally. PCM is particularly resistant to noise added when it has been modulated in the communication channel. PCM also can be processed entirely in the digital domain, allowing any desired signal alteration to be performed that would otherwise be impossible in the analog domain. After that, this is the block diagram of PCM. It has sampling, quantizing, and encoding. Next, there are two examples for PCM. For the example one, shows analog signal change to the digital signal, followed step by step through sampling, quantizing, and encoding. For the first signal is the analog signal, which is an input signal. Second signal shows sample signal by sampling. Then make encoding and decoding signal. Lastly, we produce signal. Lastly, we produce a square signal, which is consist by digital signal. After that, we move to the example 2, which is to produce a receive signal using compounding and without compounding. This is the code for the example 2. This is a receive signal graph using compounding. Next, and this is the receive signal without compounding. For the exercise 1, what is the frequency of the analog signal that has been used in the example 1? As we know, formula frequency is F equal 1 over T. From signal in example 1, it needs 100 seconds to complete one cycle signal. So we input the T, which is 100 seconds, in the formula. So then we will get the frequency is 10 millihertz.
Good day, sir and friends. My name is Jevitha Gunalan, and my metric number is B0820100345. So my part is the second question. To generate a 2K kilohertz sinusoid with a peak-to-peak voltage of 2V, bracket positive or negative 1V, and generate a quantized signal band n equal 8 and n equal 16 levels, and then calculate the signal to quantization noise ratio SQ and R. So this is for the question 2 coding for n equal 8. Here I put t equal 0.5 double dot 0.0005 double dot 1, this for time, and the x equals sin c bracket 2 multiply by pi and multiply by t for message signal, and c for compound bracket x comma 255 comma 1 mu mu or compressor E equal U encode C break C comma 8 D equal U decode E comma 8 O equal compound bracket D comma 255 comma 1 comma mu or expander. So for figure 1, hold on, plot x comma rate, plot 0 comma black, h lag equal lagging original signal comma receive signal using compounding, hold off, e1 equal u encode x comma 8, d1 equal u decode e1 comma 8. Figure 2, Scroll down, plot X, comma red, plot D1, comma green, H leg equal legend, bracket original signal, comma receive signal without compounding, and although. So I ran my coding, and this is my output. For figure 1, the red line is original signal, the black line is received signal using compounding. For figure 2, the red line is original signal, and the line receives signal without compounding. This is my output for n equal 8. And the second one, same as the n equal 8. Here we need to change the, for E code, EUN code, we need to change for 16. DU code, here also 16. And then for E1 undercode X bracket 16, D1 undercode E1 comma 16, and the others same like n equal 8. So I run the output. This is the output. For red line is original signal, for black line is received signal using compounding. This one is original signal, received signal without compounding. This is for n equal 16. And for the calculation, n equal 8, dr 20 log 2 cube equals to 18.06 d. For SNR, 18.06 plus 1.76 equals to 19.82 dB. For SNR bracket Q, 10 log 3 bracket 2 cube square. So total got 22.83 dB. This one for SN, this one for n equal 8, and this one for n equal 16. The calculation for dr is 20 log 2 times 4, 2 square, 2 2 4. So I got 24.08 dB. For SNR, 24.08 plus 1.76 equals to 25.84 dB. For SNR Q, 10 log 3 bracket 2 4 square, I got 28.85 dB.
For exercise 3, use the MATLAB Simulink for question 1 and question 2. So this is the Simulink for question 1. First, the signal generator and pulse generator at the beginning. We go to dot product, and then we'll proceed to uniform encoder, uniform decoder. So we have 4 scopes. Then for output for Q1, we get a sample signal and analog signal. And then next, for scope 3, we get a uniform decoder. For scope 2, a uniform encoder. For scope 1, we get square. And then for Simulink for question 2, so we have 2 types, which is without compounding and with compounding. So without compounding, we have a signal generator, uniform encoder, uniform decoder, and scope. And the difference with compounding is we add on the mu law compressor and mu law expander. So for the 2 kilohertz with 3 bits, for without compounding, this is the signal we get, and without compounding, we get this kind of signal. And for 8 bits, without compounding and with compounding, so there's no much difference between them. And for 16 bits, without compounding and with compounding, also looks similar.
For this assignment discussion, we can conclude that post-code modulation, above that we did, we can say that it can encode a message by converting them into binary bits. Besides that, this can be called source code. Moreover, we found out that PCM is resistant to noise and can process digitally. And pulse code modulation also can only be used in the digital domain and cannot be used in analog domain. The analog domain converter is used to convert the continuous message signal into the digital numbers. That means each number represents a level of the quantized message signal. As soon as the quantized signal that I mentioned is in the digital domain, it will be much more easier to generate signal processing by only applying the required mathematical equation. So next conclusion, the conclusion that we got from this project is we learned that PCM pulse modulation, and we have discovered its advantages and disadvantages. The example of the advantages were convenient for long distance communication. Besides that, it has a higher transmitter efficiency and has a higher noise immunity. Besides that, CM also got the disadvantages that were it requires large bandwidth as compared to analog system. Secondly, is encoding, decoding, and quantizing circuit of PCM is very complex. PCM are widely used in the satellite transmission system. They are also used in space communication and telephony. The compact disc CD is a recent application of PCM. Right, thank you.